Test. Hello. Cool. Okay. I think we are live. We've improved our streaming setup a little bit thanks to Perry, who's also on the line, but you can't hear him. And we are going to get started. I'm pulling up my slides, and then we'll get going. Also, I have thoroughly reworked and broken things many times over the past 12 hours. So there's a good chance we'll get to do some fun things live to fix it, it's all part of the process. So if that happens, happy little accidents. Let's get rolling. I'm gonna start with my desktop here, and we should be going. I'm gonna wait for Perry to tell me that you can see my slides, which might take 5 or 10 seconds, and I'll get going. Cool. All right, so welcome to the second session of Metasploit Summer. Today we're going to be looking at Metasploit versus other tools. This turned out to be a really fun deep dive for me, and I'm going to end up breaking this into multiple streams. We're going to do a couple of these live at DEF CON, so if you're around and want to hang out and watch us hack, please reach out. We'll have swag and jokes and caffeine and probably alcohol too. Who am I? I'm our jackhammer of all trades at Startup.Security, the founder. Spend most of my time doing security engineering, which is anywhere from managing our SIEM to doing making some offensive tooling. Enough of that for today. We're going to compare the Metasploit way to other popular approaches. So we're going to talk about Metasploit versus the world. We're going to get into meta pen testing, which is a quick review of some of the things we talked about last time in terms of us having our own mental frameworks for pen testing being very crucial for us being effective pen testers. I'm going to show you a new sandbox we made, which is live on GitHub, so you can play with it. And then the two big things we're going to look at is Recon, which is Metasploit versus Nmap, and then Initial Compromise showing Metasploit versus Hydra. And then this foothold in conclusion, I'm going to tease some of our next content coming up, which I'm really excited about because a lot of the things we're going over today are pretty basic, but with the foothold stuff, we get into some really interesting waters. So hopefully I'll give you enough of a exposure today that you'll be really interested to come back to hear the whole thing, or us going much deeper. So Metasploit versus the world. This is a little bit of review. So we're always working on improving our discipline of pen testing, whether you're just getting into pen testing or you've been doing it for a while. We talked about the importance of thinking of Metasploit not just as a tool, but a framework. And so it was built so that we could have little Lego pieces that we plug in to this larger tool that automates large swaths of our repeatable process, and understanding the trade-offs between using Metasploit, leaning on our own tools, or some blended approach. And so why do we need a framework? Again, this is a pretty common trope from the development world, which carries over really well to security engineering. Whenever you start as a developer, there's big frameworks like Rails is a pretty popular one you've probably heard of. And so as you begin with Rails, you're like, oh, this is great. And then somewhere in the middle of your journey, you're like, no, I have to customize every last piece of this. And then further along, this is the tweet of the midwit, you're like, no, frameworks are actually great. I understand them enough to customize them, and this helps me move a lot faster. And I think that my premise is the same thing is true for something like Metasploit. Again, Metasploit doesn't need to be your end framework, and the reason we're doing this is not to sell you on that, but rather to approach pen testing through the lens of having our own frameworks that we're confident in. And so that's where today we're diving into this crying midwit part of it, is looking at some of the other tools and understanding the trade-offs between leaning on something like Metasploit and using our own tools. And so in just reviews over Metasploit, we're going to be in the Metasploit console today. This is the main CLI for interacting with Metasploit. It feels like its own little terminal, which it is. And then we're going to be doing exploits, is the vulnerability, payloads, what we deliver to the victim. The database, we're going to talk about it a little bit today, but not lean on it too heavily. And then the more advanced stuff that we're going to get into in a future stream is Meterpreter. I never say that out loud, so fun. Cool. So meta pen testing. Metasploit is not our actual framework. It is a manifestation of our framework. There are all kinds of frameworks that we rely on professionally. MITRE ATT&CK framework is one of the common ones we cite. There's others. The thing that we're going to look at today is our modified version of Red Team Operators Framework. There's a post by Mandiant that I will link in the notes at some point it's on the slides. I'll share those out too. But this is the main framework the overview of the framework we're going to do today. We're going to start with recon. We're going to find an initial compromise, which will lead us to a foothold. And then once we have that foothold, that is when we breach the initial perimeter, and then we can cycle through this attack loop where we move around inside our target, and eventually we'll complete our mission. And so let's step back for 1 second and look at our sandbox. One of the things that you may have noticed last time we talked, I find it really important to be able to run my own tools. It's nice to not have to worry about whether my ISP gets mad, whether my data provider gets mad. I like to be able to run everything locally so I can just abuse the tool to my heart's content without worrying about accidentally running the tool on something I don't want to. So last time we looked at VulnHub, which is great in a lot of ways, but it's really heavy to run VMs for everything. So between when we last talked and now, I made something called Very Safe and Friendly Network, which I'll pull up the source code in a second and we'll talk through it, which allows us to use either Docker Compose 100% locally or something like Tailscale plus Docker, so we can spin up most of our own local stack in a way that's really easy for us to just read the Docker file and see exactly what vulnerability we're spinning up and run it in a realistic network. So we can spin up Docker locally, and then I can connect to it with even an external computer in my Tailscale network, and we can run our attack against. So this took a lot of my time between when we talked last, but I'm pretty happy with how it turned out. So let me just take a quick detour here, and I'll throw this in the let's see. I hear you, Perry. We'll have to fix that next time. Sorry if there's some delay between my video and the slideshow. So looking for the YouTube chat. Boom, boom. Nope. Let's see if we can paste this. Cool. So there's the GitHub link. And so we're going to boot this up in a second. What does it do? We have a series of boxes that we've made. I'm going to show you how clear this is to look at. And so this is one of the main boxes we're looking at today. We are standing up an SSH with a purposefully weak username and password. So a pretty trivial example, but very cool that we can express this in pretty easy code. We could even generate passwords and test out some benchmarks for other tools. Here's another one. I put together a very small, that's the first time I wrote PHP in like 10 years, but an intentionally vulnerable PHP app that we can look at, and that's where we're going to end the stream today, is looking at that app. How does it work? If you go in here, we can look at the makefile, and I've added all of the Docker build and run commands. And so that means when we go to our terminal here, you can see that I have Docker PS. I'll clear that. PS. We can see I've got our basic password, our PHP easy password, and then I actually have a Metasploit and Kali box running in our Docker Compose cluster, so you don't even have to boot your own Kali or Metasploit. And so in a second I'll just attach to this real quick so you can see Docker exec -it, and we can. So what this is doing is it's attaching to this running container, which is our Metasploit container, and we're running into a bash shell. So this is interesting. It's the actual development version of Metasploit. So there might be NSF console. You can see we'll see I have a few extra development noise, but it's going to be the latest version of Metasploit that we're using. So yeah, we'll look at that more in 2 seconds when we actually get into running our things. Okay, so we looked at that, and so cool. Let me actually show the Tailscale plus Docker, and so let's go ahead and that was quick. Okay, so I'm running Tailscale, which if you don't know what Tailscale is, it's like WireGuard with fancy boots on. So WireGuard is a peer-to-peer VPN, and it allows us to create a distributed virtual network, essentially. So here inside I'll run Docker PS again, you can see the containers, this SSH basic password and PHP easy password. If I shell into one of these with Docker, so I can do this one, do Docker exec it bin bash, and if I do Tailscale status, you'll see that this is one of the boxes that we have running inside of Tailscale. Failed to dial. Nice. So we can do user share. /bin/join. This is let's go cd user. To explain, this is one of the things I talked about we could run into. Cd bin? No. Let's see, where did I put that? History. Let's look at. So pulling up cursor, which is my IDE, we will pull up our shared files here. So we see join Tailscale is the file we're looking for. Okay, cool. So let's exit this for a second. I'm going to stop and start this container so we can look at the logs. Docker stop. And so this is the PHP easy password. While that stops, I'll show you the make file we're going to run. So here, it's actually good because I can make sure I'm not going to share my Tailscale key to everybody. So we're just rebuilding and rerunning this file. And in it, we have the start.sh, which should run to join Tailscale. So user local bin join Tailscale. But we're going to do launch PHP. Conflict containers already in use. Great. Let's look at that. Doesn't look like it's in use. So we're going to do Docker ps-a to see all of them. So we're going to, instead of stopping it by its name, we're going to do Docker stop. Okay, great. So let's restart it. Already in use by, cool, let's stop this container. Let's remake it. Conflict is already in use. So let's look at the Docker desktop app and see if we can have any extra visualization here. I see exited. We're going to delete it. Delete forever. It's scary. Make. Nice. Wasn't in use now. So now that we have remade this, let's look at the Docker logs dash in 200. So now we're going to look at the logs coming out of the server. So I see PHP development server started on 80. Let's scroll up and see failed to log into Tailscale. Awesome. So that's actually good. We see that there's an issue here. So I don't spend all of the time streaming resolving this. I think there's lots of interesting things we could go over here, but I'm actually going to ignore Tailscale not working for now, and we're going to lean on the Docker Compose version. And so that doesn't require Tailscale for the moment. Awesome. First live coding issue, but I think that's actually fine. It kind of allowed me to walk through how this should work. And the solution to this is going to be something silly. So failed to log into Tailscale. I'm going to have to go look at the Tailscale logs, and I'll push up a PR to fix whatever this failed. But it's probably something with me continuously deleting and recreating the container. So we're going to move on for now, and I will show you the Docker Compose version. And if this doesn't work, we'll be in real wild waters, but I think it'll be fine. So here, you can see Docker Compose, and let's look at that file real quick so you can kind of understand. So inside of networks, I have a kitchen sink network, which I have stood up a lot of these boxes on. And we can see exact same images. We have PHP easy password, SSH basic password, Kali Linux, and Metasploit. And we can see I added a few parameters. We have these boxes running here. So let's log into, we logged into Metasploit. Let's log into Docker exec-it bin bash. And really cool, so if you've used Kali at all, you'll notice this is the default Kali shell prompt. So, and we are in a mostly installed version of Kali. I've made it a little bit lighter weight, but has everything that we could want for this exercise. And so we have that. Let me just check the chat real quick to make sure nothing too wild's happening. Great. Let's keep going. Since Perry hasn't yelled at me, that either means he can still see everything or my call disconnected. Okay, so let's go back to our next order of business. We can see this working all locally. We can see, I showed you the Docker logs, and let's go ahead and do a quick nmap scan. So whenever we are in a network, let's do ifconfig. Nice. So apt-get install net tools, I think. Sudo apt-get install. When I said this was a stripped down version of Kali, that means I didn't install nettools, which happens to be where ifconfig lives, I believe. Great. Okay, so we have our loopback interface, and then we have this one right here. So this is our IP address. And if we do nmap, sn, and so the thing that I want to see is like, okay, cool, we're in our Kali box. Let's see what who our neighbors are. So let's scan this. Not npm. We're not developing. I want nmap. Nmap sn 172.16.238.0.24. So this is the gateway for our very friendly and safe network, and we're running it. Cool. And so now this is a port scan via nmap, and we can see our Metasploit box, which is on the same network, PHP easy password. We see our SSH basic password, and then we have our current host. Cool. So this is great. And that is actually the first part of Recon, right? It's just seeing who's out there. So in case people are newer to security, we have nmap, which is a port scanner. Well, it does a handful of things. It can discover hosts on network. We can look at those hosts and scan their ports, which we'll do in a second, so we can figure out what's running. And it has more complicated, different type of vulnerability scripts and service fingerprinting identification stuff it can do. And so this is a very canonical way that we could start to approach looking at a network that we're trying to penetrate. And so the question we answer is who's on the network. And we did this. Let's use, I'm going to try a different view to see if I can get my terminal and my slides in the same screen. So bear with me for 2 seconds. Presentation plus terminal. That does not instantly look right, so I'm not going to overcomplicate it. I'll just flip back and forth for now. So we saw this is the Nmap version for Recon. Let's go out of here. Let's look at Docker PS. We see Metasploit. Let's go ahead and shell into that box. Docker exec. So this is running a command. We're attaching to this running container, and the command we're running is bash. So that gives us a terminal. So just like opening up a terminal like you would usually do. And this is, what's that, Perry? Oh. Perry said I dragged my video in the middle of the screen. So presentation. I think that's going to be better. Main desktop. We'll go with main desktop for now. Okay. I think that's going to be better. Perry, if that looks better, could you let me know? Okay. Perry's saying it's going to take a minute to catch up. So I'm going to assume it looks good, and I'll kind of just explain. In the meantime, we're back in our version of Metasploit, which is the development version, so it might look a little bit different. All the same commands are still there, and it works mostly the same, with a little extra noise. Did you say that was good, Perry? Perfect. All right, so here we are in Metasploit, and so in Nmap, this is what it looked like. We did Nmap SN, which is an ICMP sweep. In Metasploit, it doesn't actually have the exact same thing, so we're going to use something called an ARP scan, which is similar. And so use auxiliary scanner, what was it? Discovery, ARP scan. First thing I do when I load up anything in Metasploit is run the options command, and that will show you what arguments are required. And so here we know we want to basically just need to set this R hosts, which is the remote hosts. And so I'm going to do Control-Z, ifconfig, just double checking which network we're on again. I'm going to copy and paste it so I don't mess it up. Control-Z is very similar to background. It just suspends the process. We're going to do that to %sign to get it back. And we're going to set our hosts to 024, which is the gateway with a CIDR mask on it, so it should scan a good chunk of this local network we're on. Final check, we have the only required, we could beef up the threads and mess with a timeout, but since this is our own network and it's pretty small, it should be fine. So we're gonna run. Cool. And so we see very similar, a few small details I'll point out differently. One is Metasploit's aware that our current host, we're on .3, our current host doesn't show up, which is just a nice little contextual benefit we have from Metasploit, which is consistent with using a framework. You get nice things like this. Another thing, if we're running a database, these go into more of a cache layer. And so with Nmap, we're having to do additional work to figure out how to store and rescan these things. But pretty similar results. Next, let's move on from here, and natural next step is figuring out what ports are open, right? And so in order to do that, And again, Nmap, there's so many little switches we can throw in there, but we're just going to do very basic -P, which will scan a whole port range for us. And let me actually just open a separate tab so we don't have to keep exiting. So Docker ps, let us get back into Kali Linux. We want this one, DC Kali Linux. So we want a Docker exec it bin bash. So this is attaching again ifconfig. So we did not close this container. As soon as I close this container, I'm going to have to reinstall NetTools. I'll need to update that in the GitHub repo. So if you pull it down, you should not have to do that. But again, this is hacking, right? So we have to adapt and overcome. So here's our IP address here. And so we can look up to this subnet, and we can do nmap -p for all ports. And then we throw our CIDR mask on top of that. Gosh, sorry, I've written too many JavaScript programs. I keep typing npm instead of nmap. And that's going to run for a second. Cool. And let's look through here real quick. So we see one with 22 and 80 open. .1. We see, which one is this one? This is Metasploit. No, should not really have any open ports. We see this 172.16.238.4 with port 80 open. This is consistent because it's our PHP. This is the Apache server running. We have our SSH basic password container with port 22 open, unsurprisingly. So that's good. And let's run the same type of scan in Metasploit now. So let's just restart it so we get a nice fresh session. Reloading MF console. And we're going to use this auxiliary scanner port scan TCP. And so once that auxiliary, I already forgot, scanner port scan. Scanner port scan. And just for reference, I use the docs and AI a ton when I'm using Metasploit to try to remember all of these things. Nobody needs to have all of this memorized unless you just do it constantly. And so similar thing, we're going to set our host. I see that's our only required setting with no default value. And again, if we're running this in production, we can customize all of these attributes to make us harder to detect or to make our scan more performant. One thing to note here, the -p- scanned all ports. I'm just scanning 1 to 10,000. We would have to manually add, 60,000. I can't remember how many ports there are, somewhere around 60,000 to get all of them. And so our remote hosts, did we? No, we did not. Cool. Let me suspend this real quick so I can get copy-paste version of that. Unsuspending with a %sign. I'm going to set our hosts .3 as our address. I'm going to throw on the /24 CIDR mask, and I'm going to run. Invalid option, our hosts. Let's look at my notes real quick. Okay, so for do I just set the gateway? Let's try setting the gateway. Maybe we don't have to give a CIDR mask. No, we are scanning a specific IP, right? We're not scanning a whole range at this point. So that's one difference from Nmap. And so we're Nmap, I scanned a range. For open ports, we're just going to scan a single host here. And so let's look up and see what host we want to scan. Let's just go ahead and redo this one right here, this 172.16.238.5. Set our hosts, run. Cool, so it's running. This is interesting to run into because it is showing how the act of using Metasploit over time will influence the way that we have to test, right? And so we're probably running these loading these into a database and having to do a larger, more involved type of scan to get this. But the results of the port scan are exactly the same. And so cool. That brings us to the end of our recon. We're going to move on to compromise next. So just a little recap. Metasploit has some niceness in terms of structuring the output, saving and caching the results. However, we're already running into limitations where I could flip a few switches in Nmap, which I know how to do real easily. Trying to finagle the right settings, in particular in Metasploit, is way more involved. For example, there's the ARP scan built in. We could totally build an ICMP or maybe find an ICMP scan to run, but it's just not as easy in this particular case as changing a few flags. But in a future stream, this might be, we might build a custom port scan or leverage Nmap inside a custom port scan using Metasploit to show how that would work. So just observations, no conclusions here. This is not about making conclusions. This is just about evaluating Metasploit and becoming better at hacking. So let's move on to the initial compromise. So we need to find something that's wrong. And I mean, I know it's wrong because I built the image. The thing we're going to do is we're going to brute force a password. And this should never be a bug that you find on production, but it happens quite often. People use default passwords or weak passwords on production systems all the time. If not production, often staging, and then staging can get you into interesting places. That's probably what we see more in practice, but just notes. Cool. So the tool we use to do that is Hydra. There's other tools, but this is kind of just the OG one for doing password brute forcing. The cool thing about Hydra, especially if you come and read, it is written in C, so it is blazing fast. It also supports a ton of different protocols, and it's meant to expand, right? And so you can see anywhere from Postgres to, memcached, IMAP, ICQ when that was a thing, like lots of options here, including SSH. So let's do that. We'll close this so I stop getting confused. So now we are going to brute force and see if there's a simple password. Let's start with just doing it via Kali. And so again, this is our IP we want to attack. Our host equals, if we want to get fancy and do that, echo our host. So it feels similar, Hydra. There's more complicated things we could do to scan usernames and passwords, but just for Goldilocks effect of running this, I know that the username is admin. Maybe we found a credential. Maybe we are testing the default credential with custom username. Sometimes services will do that where they'll set the default administrative username and then make you set a password. So this is a not unrealistic way to do it. And we're going to specify a password list, which is user share word. Nice, word lists are not installed. So we have to install them. Let's guess. Sudo apt get install word lists. Okay, I do not recommend guessing, but I think this is the actual package because I see it from Kali. Give it 2 seconds. We're pulling it in right now. For those of you who don't know, Kali comes with a bunch of word lists that we can use. So let me actually show those. User share word lists. You can see, we'll just use this. John as in John the Ripper, but there's a bigger word list package you can install, but this will be enough. So if we cat out, let's see, user share word list, john.list. If we look at the last few, you'll see it's just kind of silly passwords that are common. There's better lists to use, but we'll use John to start with. So back to our Hydra. And let's just make sure Hydra is installed. Great. Hydra -L. Let me look at my notes real quick. For admin -P for, obviously P would be word list. User word list John. And then we need the IP and the protocol. So the IP we set as a variable called rhost and SSH. Boom. Instantly found admin password because it is the weakest one to set. So this is, we just brute forced our own server, and just for giggles, let's go ahead and admin at rhost. So if we do this, typing out password, we have root access now. Great, cool. So let's do the same thing in Metasploit. And just for grins, our host, let me copy pasta this as our IP we want to attack. So if we come in, we'll start a fresh console session. SF console. Again, these are just dev errors. Please ignore them from the version of Metasploit we're using. And then let's just look over our notes real quick. It's auxiliary scanner, SSH login. There's such a good chance we don't have a word list here too. Let me just, let me exit. Is it APK for this? I'm guessing. APK install word lists. APK add word list. Cool. Let me grab my notes. There's another much larger word list we can use that I have in the README. Shut the door. Yeah. Okay, so we're pulling this. This is a word list called RockU. It's much larger. So it'll take just a second. And this one's pretty common if you are out on the internet. Maybe you have seen it. So let's go back to our Metasploit console. Let's just tail this out. User share word list rocku.txt. Okay, this looks like correct enough. Let's get in here. MSF console. Boom, loading it up. Let's double check that we have our auxiliary scanner SSH login. So use auxiliary scanner SSH. Nope. Scanner SSH login. That's it. Let's check options. Let's grab our host. We're going to have to recopy over here. Set our host plural. So we're attacking this specific one on port 22, pass file. So let's set pass file, and that's user share word lists rocku.txt for the win. That will complain at us if it's wrong. Set password or set username. We know that that's admin. We had to do the same thing with the last one. Let's run it. So this might take a second longer because we're brute forcing with a much larger list. Also, I should have set this stop on success. Cool, so it found the exact same thing. Another thing you'll notice right here is one SSH session opened. So it actually went ahead and opened the session that we can connect to. And so we're gonna stop there, and we're gonna start wrapping up for today. And so our results, Metasploit has a lot of nice things it does, even just knowing to start the session and track the session after we're done brute forcing. However, it in some respects feels very limited as an independent tester. I don't want to say limited, but rather it would require a lot of configuration to use consistently, in my opinion. And I mean, it has. We've tried to do this personally. And so next time we're going to go over footholds, which I think is a super interesting concept. This is crafting, delivering a payload, opening reverse shell, and maintaining some amount of persistence. Yeah, I tried to fit this into this stream too, but it just is a much larger topic, and I wanted to do it justice. Cool. So this is going to be continued. Again, next time we're going to talk about extending Metasploit and showing how we could build our own tools inside of Metasploit and use them. And then at DEF CON, which if y'all are going, please hit us up. We'll have merch and we'll be there to hang out. We're going to do probably a Metaterpreter deep dive, however you say it. And then also, one of the big tools we use is Burp. I have an intentionally vulnerable web app that we have to hack. And so we might put that on a network that y'all have access to and let y'all try to hack it too. It'll have a bit harder of a challenge than just admin and password though. So I think we're going to end there for today. Let me just look at our thing. Great. If y'all have any questions or comments, please reach out to us on the internet. We'd love to talk. And I'm going to go ahead and wrap it up there. But first, I'm going to transition to our nice loading screen.